In this lesson, we will explore the big ideas that are involved in real-world problem-solving and innovation. Problem-solving involves a task with a defined challenge for the student. Problem-solving happens when students must develop a solution to a problem that is new to them, or complete a task that they have not been instructed how to do, or design a complex product that meets a set of requirements. Learning activities that require problem-solving do not give students all the information they need to complete the task, or specify the whole procedure they must follow to arrive at a solution. When students are working on problem-solving tasks, they are engaged in some or all of the following activities: investigating the parameters of the problem to guide their approach, generating ideas and alternatives, devising their own approaches or exploring several possible procedures that might be appropriate to the situation, designing a coherent solution, as well as testing the solution and iterating on improvements to satisfy the requirements of the problem. To count for this rubric, problem-solving must be the learning activity's main requirement. The main requirement is the part of the learning activity that students spend the most time and effort on, and the part that educators focus on when grading. Think about these situations and consider if problem-solving is taking place. Students read a story and then take a quiz about what they have read. If students must rewrite a story from the perspective of a character other than the narrator, is this problem-solving? Are students engaged in problem-solving if they learn about pedestrian safety by studying a map showing bus stops and pedestrian crossings? If students use a map of a bus route to propose where pedestrian crossings should be added in a fictional town, is this problem-solving? Are students engaged in problem-solving if they are using Microsoft Excel to calculate the mean, median and mode of several sample datasets? Are students engaged in problem-solving if they identify appropriate situations for using mean, median and mode by exploring several sample datasets in Microsoft Excel? Quite often you will hear the phrase real-world problems, but what does this mean? Real-world problems are authentic situations and needs that exist outside an academic context. These real-world problems have a number of common characteristics, which we will explore in the following slides. Firstly, real-world problems are experienced by real people. For example, if students are asked to diagnose an ecological imbalance in a rainforest in Costa Rica, they are working with a situation that affects real people who live there. Secondly, real-world problems have solutions for a specific plausible audience other than the educator as grader. For example, designing equipment to fit a small city playground could benefit the children of the community. Another characteristic of real-world problems is that they have specific, explicit contexts. For example, instead of learning which vegetables grow best in which parts of one's own country, students who are engaged in real-world problem-solving would develop a plan for a community garden in a public park in their own town. This learning activity has a specific context, but the other activity does not. A final characteristic of real-world problems is if students are using data to solve a problem. They use actual data, not data developed by an educator or publisher for a lesson. For example, students will use real scientific records of earthquakes, results of their own experiments, or first-hand accounts of a historical event. Think about these situations and consider if they are real-world problems. Students rewrite a Shakespeare play in a new rhyme system. If students rewrite a Shakespeare play for a teenage audience, is this a real-world problem? If students use a bus map in a textbook to propose where pedestrian crossings should be added in a fictional town, are they engaged in real-world problem-solving? If students use their own town's bus map to propose where pedestrian crossings should be added in their own town, are they engaged in real-world problem-solving? Are students engaged in real-world problem-solving if they investigate the interaction between green plants and carbon dioxide in the air? Are students engaged in real-world problem-solving if they investigate whether growing plants in their classroom can improve the air quality? Is this a real-world problem if students identify appropriate situations for using mean, median and mode by exploring several sample datasets in Microsoft Excel? In a learning activity, students identify appropriate situations for using mean, median and mode by exploring several sample datasets in Microsoft Excel. Now consider, how could you redesign this learning activity so that the students are engaged in real-world problem solving? We would encourage you to go to the discussion section to share your views and ideas about this task redesign with others. Now that we've explored what we mean by problem solving and real-world context, let's explore the next idea: innovation. Innovation requires putting students' ideas or solutions into practice in the real world. We will discuss and explore this idea in greater depth in the following slides. For example, it is innovation if students design and build a community garden on the grounds of their own school. However, just designing the garden alone is not innovation. In cases where students do not have the authority to implement their own ideas, it is innovation only if students convey their ideas to people outside the classroom context who can implement them. For example, it is innovation if students present their ideas for building a community garden in a public park in their town to a local environmental group or to local officials who could implement the students' ideas and design. But it is not considered innovation if students design a community garden for that public park and only share their plans with their teacher and classmates. Innovation also benefits people other than the student. In other words, it has value beyond meeting the requirements of a classroom exercise. For example, the townspeople who tend the new garden in the public park and the teenagers who attend the rewritten Shakespeare play benefit from students' efforts. It also counts as innovation if students create a project for a science fair or submit an original poem to a regional poetry contest, for example, because the fair and contest are not educator controlled and have real audiences who are interested in and may benefit from the students' work. Think about these situations and consider if innovation is required. Students rewrite a Shakespeare play for a teenage audience but do not perform it. Is this innovation if students rewrite a Shakespeare play for a teenage audience and perform it at a local youth centre? If students write letters addressed to the town council about improving pedestrian safety but only give the letters to their educator to grade, is this innovation? Is this innovation if students write letters to the town council about their ideas for adding pedestrian crossings in their town and mail the letters to council members? Think about this situation and consider if there is innovation required. Students investigate 2 or more online websites or games and develop a presentation using Community Clips and Windows Movie Maker about Internet safety guidelines for parents and students to be aware of. Their product is handed in for a grade. Is this innovation? Students investigate 2 or more online websites or games, develop a presentation using Community Clips and Windows Live Movie Maker about Internet safety guidelines for parents and students to be aware of, and present their products at Parents' Night. Is this innovation? Students analyse data about the basketball team and use Microsoft Excel to graph performance patterns for the overall team and individual players. In the previous learning activity, students analysed data about the basketball team and used Microsoft Excel to graph performance patterns for the overall team and individual players. Now, what we would like you to consider is how you could redesign this learning activity so that innovation is taking place. We would encourage you to go to the discussion section to share your views and ideas about this task redesign with others. In the next lesson, we will consider how to redesign learning environments that require students to engage in real-world problem-solving and innovation.